Okay, in this video, we're going to see how to convert this right here to Cartesian, meaning that at the end, we should only have x and y in our equations. And of course, here are the ingredients for you guys. Let's start with the first one. We have r is equal to 4 times secant theta. Oh well, we see that this is cosine theta, and the connection between cosine and secant, of course, is just that we can take the reciprocal of this. So, for this one, we can just write down r equals 4, but for the secant theta, take the reciprocal, so we end up with r over x for secant theta, like this. And of course, we can just work this out. Perhaps we can multiply the x on both sides, so we get x times r, that's equal to 4 times r. And because both of them have the r, so of course, let's divide both sides by r, and we end up with x is equal to 4. And that's going to be a vertical line, right? When x is equal to 4. And at the end of the video, I will show you guys the graph of all this on the screen, right? So you guys can just wait for that. I'm not going to graph it yet. All right, for the second one, okay, let's go ahead. R is r, tangent theta. It's very nice because this is y over x. So of course, we can totally just put that down. And then for secant theta, again, it will be just r over x, like the one that we did earlier, like this. Now, as we can see, we have x times x, name the x squared on the denominator, so we can multiply the x squared on both sides. Therefore, we have x squared times r, that's equal to y times r, like this. And then, of course, divide both sides by r, and we end up with y is equal to x squared. Of course, this is the famous parabola, so it's like that, right? Okay, for this one, notice how we have r squared times cosine of 2 theta. This is cosine of 2 theta. But we only have cosine theta, sine theta, right? Don't worry, because we have the double angle identity for cosine. And we have 3 versions for the double angle identity for cosine 2 theta. Well, this is the version I'm going to use. It's going to work out really nicely. I'm going to keep the r squared on the outside right here, and then open the parentheses. For cosine 2 theta, this is equal to cosine squared theta, and then minus sine squared theta. And of course, this is still equal to 1, like this. Why am I using this? Because you'll see the cancellation worked out really nicely. And let me show you. We have the r squared on the outside, and the cosine squared theta. This means cosine inside, and because cosine is x over r, so of course we can just put that inside. This is the cosine. And don't forget, we still have to do this to the second power. And then we do the same for the sine square. So open the parentheses square. For the sine though, it's y over r, so I'll just put that down right here. And this is, of course, nicely equal to 1. And then you see that this right here is just r squared times, and of course we can work this out, x squared over r squared, and then minus y squared over r squared. This is equal to 1. Very nice, because when we, square, right, r squared. This is very nice because if we distribute the r squared, they cancel. So in the end, we just get x squared minus y squared equals 1. And of course, this is the hyperbola that we have seen before. All right, last one right here. Actually, I can just graph it off for you guys. This is when x is equal to 4, right? So this is the vertical line. And this right here is, of course, the parabola, so it's not so bad at all. Y is equal to x squared. And this right here is hyperbola, so I will just put this down right here. So it will look like this and like that. Okay, so this is x squared minus y squared equals 1. When x squared goes first, that's the left and right hyperbola, right? Okay, so for the last one, well, let's go ahead and do the following. R is r, 6 is 6, and then sine theta is this, namely y over r. And then we see that this is minus 2. Cosine theta is x over r, like this. And that's very nice. Now, let's go ahead and multiply everybody by r. So let me just put it down in green, so I'll make this slightly more clear for you guys. As we can see, on the left-hand side, we end up with r squared. And that will give us, this times that will cancel, so we have just 6y minus 2x only, right? So that's what we have. And then, of course, we see that we have the r squared. For the r squared, we can replace that with this, namely x squared plus y squared. So x squared plus y squared for the r squared right here. And let me change color to make it prettier for you guys. X squared plus y squared, right? And of course, this is equal to 6y minus 2x. What kind of equation is this? In fact, it's going to give us a circle. And how can we see that? Well, we are going to move this to the other side and we'll complete square and we'll see. So let me write down x squared plus 2x, and then I'll leave a space for the magic number. And then I will add y squared, move this to the other side, that's minus 6y, leave a space, and this is equal to 0. And now for the magic number here, what we do is we take half of this. I will write it down right here. I'll just put it down here, right? We are going to take half of this coefficient because the 1 in front of the x squared already, right? So take half of that, 1/2 times 2, and we square that, which will get us 1. So that means I will have to add 1. And don't forget to do the same on the other side as well. Then we look at this, which is negative 6. And we take 1/2 of negative 6. And again, we square that. Work this out. You see that this is negative 3 inside. Square that, we get a positive 9. Well, right here, we can just add the 9 here. Likewise, on the other side. So that's what you have. And then we see that this right here, we can factor it. This is x plus 1 squared. And this right here is y minus 3 squared. And all in all here is equal to 10. So this right here is it. And you have to notice that this right here describes a circle. And we know the center of the circle as well. Let me just tell you. This is a circle, and we have the center at negative 1, positive 3. And then in the end, the radius. Notice how this is 10, but you have to do square root of 10 squared, right, for that. So the radius is equal to square root of 10, like this, right? So that's pretty much the information. And perhaps I'll give you guys a picture real quick. We have negative 1, comma 3, let's say it's right here, right? And square root of 10 is 3 point something, so it's going to be bigger. So I will just have to probably go like this, a little bit below, and then like that. Right? So that's the circle for this one. And yeah, that's it. Hopefully this video helps.